So this is a continuation of 10.5, applications of matrices and determinants. So we're looking at Cramer's rule. So we just got done looking at an example of Cramer's rule with two equations, two variables, which, as I talked about, is not something I would do anyway because I would just use substitution or elimination on this. But once you get to three equations, three variables, it's going to make a lot more sense to start using Cramer's rule. And I know this looks intimidating, but it's definitely easier than doing the matrix equation, at least in my opinion. So a couple things to note. First off, the coefficients of A, B, C, D, E, F, G, H, I, all the coefficients of my variables. Notice that is my denominator matrix for all three of those. Okay? The second thing I would have you note as I'm going to go through to this is what I always remember, is that the JKL, the constants on the other side, notice they're in the first column, or the X column, when you're solving for X. They're in the second column, which is the Y column, when you're solving for Y. And they're in the last column, the Z column, when you're solving for Z. Other than that, the letters on top are exactly like the column right below it. BEH, BEH, CFI, CFI, ADG, ADG, CFI, CFI, ADG, ADG, BEH, BEH. All right? I do not memorize this formula, but you're welcome on your note card for the final exam to write this formula down. All right? But this is one of those things that I don't have to have this formula memorized. I don't do Cramer's rule very often. I know you guys are probably thinking like, of course you have this memorized. You're a math teacher. This doesn't come up very often. All right? But it's something that I memorize. I know the process, and so I'm able to retain it a whole lot better. So it is fairly easy it is fairly easy to memorize, yes. If I really needed to, if you were like, write this down from memory, I could do it, all right? It's not something that I just like spout off like the quadratic formula. So we are going to look at an example of Cramer's rule with three equations, three variables. I will remind you that they have to all be in standard form. So that means they all have to have X, then Y, then Z on one side, the constant on the other side, okay? Now, as I said before, the first thing I would do before I even get into this is I would figure out if this actually has a solution or not. That's the denominator. So I could write this all out, but here's what I'm going to do. I'm going to show it to you this way. I'm going to go ahead and figure out what the denominator is going to be. Okay? So if I'm looking at the coefficients 4, -1, 1, 2, 2, 3, 5, -2, 6. I want to find that determinant and see and make sure it's not 0. This is my denominator of all three variables. So I think I've copied that down correctly. I'm going to use the diagonal method that I did yesterday. Again, as I've told you before, you want to use the expansion by minors, feel free. I prefer the diagonal method. I find that it is easier for me to not mess up. I hate to say it that way, but for a lot of things in mathematics, it's all about what can you do proficiently. So as I'm doing this, I've got 4, 2, and 6, so that is 4 times 2 is 8, 8 times 6 is 48. Do the next diagonal, -1, 3, and 5, that's a -15. Next diagonal, 1, 2, and -2, that's a -4. Going this way from this bottom diagonal, so I'm going from the 5 up this way. 5 times 2 times 1, that's 10. That's the first one I'm subtracting. The next one, -2, 3, and 4. That's a -24, so I'm subtracting a -24, so it's going to end up being a +24. And then I've got 6 times 2 times -1, that's a -12. So that's going to end up being a +12. So now I need to go through and figure out what that value is. So I've got 48 minus 15, that would be 33, minus 4 would be 29, minus 10 would be 19. 19 plus 24 is 43, 53, 55, I believe. This comes out to be 55. I think this is one we actually did the other day, the same on a previous video, if you'll watch. I think I did this same exact system, and I think I even told you at the time, this is what we're going to do later on with Cramer's rule. And I did this with like augmented matrices or something like that. I don't remember which method I used at the time. But I did. So my denominator is 55. So that means when I'm doing x equals, I'm going to have a 3 by 3 on top, and then the denominator is automatically 55. So for x, negative 5, 10, and 1, those are going to go in the left column. Negative 5, 10, and 1 go here. The other two columns are going to be the same as these two columns I had here. So I'm replacing the 4, 2, 5 with the negative 5, 10, 1. So I've got negative 1, 2, negative 2, 1, 3, 6. And when I go through and do y equals, it's going to also be over 55. And I'm going to have a 3 by 3 I have to do here for that as well. But this time, for this one, kind of run into my 55 there. I apologize for that. But the negative 5, 10, and 1 goes in the middle column. So the left is going to be 4, 2, 5. And the right is going to be 1, 3, 6. And then, of course, when I get to z, I don't know where I'm going to put that. But z, again, is going to have a denominator of 55. But the numerator is going to have the negative 5, 10, 1 in the right column. And then the left two columns are going to be the same as the original denominator, 4, 2, 5, negative 1, 2, 2. So now I've got a bunch of determinants to do. Got 3 more to go. So yes, this is a little bit tedious. And I will tell you that on the quiz that we're going to have, what I will do is I will give you a system like this, and I will only have you find one of the variables. That means you're only going to have to find 2 determinants instead of 4. So I'm cutting that in half, right? So I will tell you, find x, or find y, or find z. That's a way to get around forcing you to do the entire problem, all right? But still having you demonstrate that you know how to do Cramer's rule, okay? And sometimes that's what you need. Sometimes you only want one variable anyway. All right, so let's take a look at this one. So negative 5, 10, 1, recopy that. Negative 1, 2, negative 2. So now I need to do some products. So here I've got negative 60 plus negative 3 plus negative 20. I'm going to do my minuses, put those below because I'm running out of room here. 1 times 2 times 2 would be 2 minus, and then I get 30. And then 6 times 10 times negative 1 would be minus a negative 60, so that's going to be plus 60. So I can see from here I got, these are canceling. And it looks like I have negative 55. Yes. So x, sorry I've written it up here, but I've got negative 55, and then it was already divided by 55, so it means x is equal to negative 1. Which, if you check back that other problem we did, pretty sure we came up with negative 1 for that as well. If I remember correctly, the y value turned out to be like 110 divided by 55. I think it came out to be like 2. So let's see if that actually happens here. So 4, 2, 5, negative 5, 10, 1. So again, doing products. 6 times 4 is 24, times 10 is 240. Negative 5 times 3 times 5, so that's negative 75. 1 times 2 times 1 is 2. Then I start doing my minus. 5 times 10 times 1 is 50. 1 times 3 times 4 is 12. And then minus 6 times 2 times negative 5, so that's a negative 60. So that's going to be plus. So I think this one, this one comes out to be that was the third one that comes out to be 110. This one comes out to be 165, I believe. So this should be 165 divided by 55. which comes out to be y equals 3. So there's my second one. Z is equal to -1, y is equal to 3. Finally get down to my last one here. 4, 2, 5, -1, 2, 2. That's supposed to be a -2 there, right?
Yeah.
So this is supposed to be a -2. This is supposed to be a -2. So let's make sure we have it copied down correctly. That would be helpful. I think everything else is fine. All right, so as I go through to do this one, 4 times 2 times 1 is 8. And then I get a -50. And then I get +20 minus, here I get a -50. So that's going to be plus a +50. Minus a -80. So it's going to actually be +80. And then minus a -2. So it's actually going to be a +2. So 8 and 2 is 10, minus 50, -40, plus 20, -30, no, -20 plus 50 would be 30, plus 80 is 110. So that all comes out to be Z equals 110, and the denominator is 55, so that comes out to be 2. So my order triple here is -1, 3, 2.